here are your solutions to 4-8. These are the letter problems. So we're going to start with letter A, and all they're asking us to do here is to simply graph the equation y equals 6 times x squared. So it's y equals 6 times our input times our input. So let's make a table of values with an input of x, and what is our output of y going to be? And we'll just make this really simple here. Since we only have inputs from 0 through 1, 2, 3, 4, there's no sense going any higher than that. And also we're going to recognize that our values for y can only go as high as 1, 2, 3, 4, 5, 6, 7. So it can only go as high as 7. So let's say we put in an input of 0. So if we put in 0, that would be right here. So it's going to be 6 times 0 times 0, or we could have just written 6 or 0 squared. Well, 6 times 0 squared is, of course, 0. So in the second case, we're going to have 6 times 1 squared. Well, 6 times 1 times 1, put an input of 1, would be 6, and then right away we see that if we just go as far as 6 times 2 squared, 2 squared is 4, 6 times 4 is 24. So we're way up here already. So the first thing we're going to see is that we have a point at the origin. So we can place the point right here at the origin, and we have a point at 1, and the one thing I'm going to do here is you should recognize that you can put in -1 and -6, and you're still going to get 6 and 24 for your outputs. You're still going to get outputs, but in this case, you're still going to get the same outputs, because -2 times -2 is still a positive. 4 times 6 would be 24, for example. So that's one of the things you'll just come to realize about these quadratic functions is it doesn't matter if you put in a negative number or a positive number, you get the same output. So we have a point at 0, 0, already done. We have a point at 1, 6, 1, 1, 2, 3, 4, 5, 6 would be right here. -1, 6 would be right here. So we see that we have a pretty tight fitting arc here, but this is the way our graph is going to open up. One of the things I would like you to do is, hopefully you already did this in a graphing calculator, the thing that we're going to check when we check these in class is we're going to check that your graph goes through that point right there and that point right there, because this right here proved that, and if you've got this graph right, you show that you understand how to get these values doing the math. But the other thing you can do is put it in a graphing calculator, check this. What I'd like you to do next is put in 3x squared instead of 6x squared, and you'll notice that the graph is wider. And what I want you to notice is as you graph, let's say y equals 6x squared, y equals 3x squared, y equals, we'll say 1x squared, but of course you realize you can put that in the calculator as just y equals x squared, and you're going to have 6x squared is going to be real narrow like this, 3x squared is going to be a little bit wider, and by the time you get to x squared, you're going to be like this. And you can even put in y equals 0.1 x squared, and it'll open up even wider. You should start to recognize those sorts of things. Play with these quadratic problems with your graphing calculator and really begin to understand what these look like. But it is really key that you use your table of values, an x input and a y output, in order to find, for example, with this particular problem, you need to have that point right there and that point right there on your graph. Okay, let's take a look at letter B. The outdoor observation deck of the Space Needle in Seattle. If you don't know what that is, the Space Needle is this structure that looks kind of like this, and then it's got something on the top like this, and I believe there's a restaurant up there, but it's a very tall structure. Okay, the outdoor observation deck, so it's a place where you can go there and you can observe. The Space Needle in Seattle, Washington is 520 feet above ground level. We're up here from here to here and from here to here. And this is 520 feet. 520 feet. Use the graph to estimate how far you could see from the observation deck. So this is a matter of being able to read the graph. That's what these problems really are about for examples 3 and 4, and of course this here at letter B. So we're reading the graph at 520 feet. You should recognize that we're counting by 100 here. It's 400, this would be 500, and then 600. So 520 would be 20 1/100ths, which is 1/5 of the way from one of these lines to the next line. So 520 feet, well, this would be 500 right here, so we're going to try and do this. Let's get the pen to work here. 520 is going to be right about there. That came out pretty well. So now we have to read that down here. From this point down to here, it's going to be right about there. And now when we do the math here, when we recognize that from 20 to 30, this obviously would be 25. And if you look back at this, it's probably about in the middle there. So it looks to me like it's a little bit more than halfway, so let's say it's about 28 feet or so. If you had something close to 28. Again, understand that these graphs, the thickness of the line is probably several feet, so don't get really too worried about getting 28 exactly, but let's back this out and we can take a look at this and see that it should be right about 500 would be crossing right here, which is about the halfway point here, and 520 would clearly move it over a little bit more, so I think we could see that it would be pretty close to 28 feet. 27 feet would certainly be a good answer as well. Please do guided practice.